Hello guys and welcome to episode number 24, where we will be solving 5 more SQL problems, this time from the company Virgin Airlines. So let's get started with problem number 1 right here. Find the average distance an airplane, could be a filter, from each origin airport. That would be a group by. And we have to output the result, that being the average distance, with the origin. So we have to output 2 columns. We might have a filter, but if we look here, US flights, this is definitely not a filter because every row has to have an airplane because it's a flight. Now we have to find the average distance based on the origin. So we're going to say origin, and then average distance, rename it as average distance. We're going to group by the origin, and that should be the final answer. And this is the final answer right here. Everything seems to be correct. So basically for each origin, we calculate the average distance. That's it. Very simple. Problem number 2. Find the top 5. We have to rank this. You know how we're going to be doing it. We're not going to use the limit. We're going to use a window function and a CTE table. We have to find the top 5 longest. So we have to sort descending here by distance. We're going to sort descending by distance. Then we have to output the result, which would be the top 5, along with the origin, destination, and distance. So it seems we have to do 4 columns. And then lastly, we want to order them by the flight's longest, shortest. So that would be a descending here based on the distance. Let's get started. We're going to keep this. Going to say with CTE, we're going to build our CTE table right here. We have to indent it. Now we have to select all of the 4 columns: origin, destination, and distance. Actually, it's just 3: origin, destination, distance. And now we need our rank function. Over, we're going to say order by distance descending. We're going to call this RNK. We have no filters. Now we only want to select these 3 here: origin, destination, and distance. We don't want to show the RNK column here. From our CTE table, now we only want less than equal with 5. So that would be top 5. And we're going to run this and we're going to get an error. Oh, my bad, guys. Right here you see the destination is also, it's actually called dest, not destination. So here we're going to say dest. We're going to check it again. And it seems we got duplicates. If I expand this here, this is the official solution. And we have duplicates. Now this is a bit unclear. Find the top 5 longest flights. I don't understand what's wrong with getting duplicates in this case. Longest flights. Actually, no, it doesn't make sense. Because a flight, the origin and the destination don't really change on the map. So the distance, for example, between these 2 will always be the same. And same with every other combination here. So if we actually we show the distinct origins. Right, so it seems it does not work with rank. It works with dense rank. Yeah, it does make sense, but I'm not sure if I agree with this one. We really have to find the top 5 longest flights. So a flight is between an origin and a destination. Well, that's the solution. I don't necessarily agree with it, but it's a bit unclear in my opinion. So what we're doing here, we're ranking all of the origins, actually all of the rows based on here distance descending from the highest to the lowest. And down here, we're only selecting the distinct origins where the rank is 1 through 5. Problem number 3. Let's see this one. What are the unique IATA codes? Unique IATA codes for origin airports. Origin airports. That sounds like we have to group by the origin. Now unique IATA codes. IATA codes. Well, I don't see any IATA codes here. No IATA codes, it seems. Let me quickly try something. So it seems a IATA code is a unique 3-letter code identify airport identification. That's a IATA code. We'll come back here, unique identification. Let's see what it's probably for the airport. So both of these columns right here, the origin, destination, they are formed of IATA codes. Now we only want about the origin. So literally what we have to do here is to say distinct origin. Wow, that's it. All of the distinct origins. It's just that it doesn't tell us what the IATA code is. You would have to have some industry knowledge or just Google it. Problem number 4, count the number of cancel flights. That sounds like a filter. American Airlines AA here sounds like a filter. We have to output one single column and we have 2 filters. We have to output the count of flights. Since one row is a flight, we're going to say total canceled flights. And you're going to say where. Now we have to figure cancel flights and filter by AA. Now if you look here at the data set, probably carrier would be equals AA. And now to figure out the canceled one, seems to be this column, probably is a 0 or 1 equals with 1, and that should be the solution. It seems to be fine. Total cancel flights, there are 5. So quick recap, we want to count the cancel flights from this company, AA. That's it. And problem number 5, guys, last one for today. Find all US flight. Now US could be a filter, but we have it here. So this is not a filter. Had no delay. No delay, definitely a filter. And they even tell us we have to use a arrival delay. Right. So let's check out this column, arrival delay here. We have right here. We can see it has positive and negative numbers. So some flights arrive actually earlier and some of them arrive later. I'm going to copy this one. We're going to put this filter here where this less than 1 actually. So it could be 0, which is fine. No delay still with 0. So if it's less than 1, there's no delay. Now we have to select the flights. So probably flight details. So all of the columns. And something is wrong. Let's see. You can see here there are some no values as well. Right here, a lot of no values. Now we're going to exclude those as well. So we're going to say, now we do actually a no value. What does that mean? Did it have or did it not? We don't know. So we're just going to filter it out anyway. We're going to say, or ARR delay is null. And there you go. That's what they actually wanted. So no delay. If it's null, it means it has no delay. That's what they concluded here. I wouldn't agree at all. I wouldn't even include these because we don't really know. But maybe they know, the people who did this. If it's null, then it probably means there was no delay. Anyway, that was it for today, guys. Thank you for watching. And if you enjoy these kinds of problems, I highly encourage you to join the StrataScratch community. Consider using the affiliate link in the description below. Thank you for watching, and I'll see you in the next one.